Great. Hi, everybody. Here is a simple project to figure out how to use language models to augment human intelligence and human memory. So let's see, what are we going to talk about here today? So we're going to talk about an AI-powered knowledge extraction tool from any URL or document uploads. And what you will see very soon is a live system that try to help you accumulate knowledge without you having to do the hard work of actually understanding first what you are about to read. And then a really cool technique that recently has gained a lot of attention is called the Corrective Retrieval Augmented Generation, or CRAG. And we'll give it a try to see how good it is in a real world situation. In this case, be my second brain. And as part of a benefit of CRAG is you'll get to be able to get up-to-date and accurate, hopefully accurate answers to your queries of the second brain. Okay, so how does it work? So what you're about to see is a system that allow you to enter any URLs of interest on the web or upload any file that you have. And it's going to very quickly do the regular chunking and embedding. It will do the context node retrieval, and it will do the retrieval evaluation, including if it is not good enough, it will invoke a couple of tools to help you make the answer better. So what are the user benefits? Well, many of us on a daily basis come across more documents and news than we have time to read and to understand. And so what if you have this second brain that would automatically scan the documents and not just store it, but understand it for you, so that when it is time for you to pull up the right question to ask from this document, it's able to answer that for you. Okay, so let's take a look how this works. Let's do a live demo. So here we go. So here's just a very simple system to check. So let's say, so for today, I just went to my favorite bedtime website, fda.gov. It's because it's a site that I never go to, right? And I just went there, and and there are a bunch of interesting things here, and I have not clicked on any of them. And so let's see, folic acid. That sounds pretty cool. It may prevent birth defect. Wow, that sounds like pretty cool. So I would click on it, and I noticed that, oh gosh, it's a lot of text. I have no idea what that is, right? So I make a copy of the URL. So let's say in this case, it's something about folic acid to corn mesa. Okay, so let's put it in. I'm like, okay, I don't have time to read that. So RagTime, right, parses it for me and to understand what is going on. So for those who are developers, the back end, the one thing that I find interesting about this is to take a look at how much information. So it's already done, right? It's already done the chunking. So the thing that I find interesting, the reason I have this log here is how many chunks of text did it actually create? So when this document started, in my second brain, I have 236 pieces of the document. By the time it is done, there's 241, right? So a couple of pieces of information. So let's take a look. So I want to ask, so what does adding folic acid to corn mesa do? Okay, so let's see. And so the output is also quite interesting. I did experimenting with various formatting techniques. And of course, this is running on my laptop. I guess if it is on a more powerful machine, it will run much faster. So everyone take a look, right? So this is not just a ChatGPT answer. In fact, we may want to type that into ChatGPT to what the answer is. So the first part of the answer here, respond to adding folic acid to corn mesa flour, a significant step in fortifying the significant ingredient in foods, et cetera, right? And then it provides the relevance of why this is important. And then the second part of this answer here is, this is the CRAG response, right? The famous CRAG response, which is the corrective RAG response. And so it pull up additional information to give you additional diverse answers that is not on the original homepage. So you're more than welcome to read through that. So with that, let's take a look at what is behind the scene. So, and here is the, the architecture diagram of what happened just now. So I am this little user on the left. And as I enter any query that I have, the query itself could be, hey, let me upload a document so that I can ask questions about it. And so the first thing that it encountered, there is a query router. And the query router will determine whether the question itself is something that requires whether a web crawler to do it or a document processor to process the PDF file or text file. And if the router determines that the query is not about that, then it would actually pass the query directly to a prompt template. On the other hand, the given query itself, of course, in order to get there, need to get embedded, and and looked up the appropriate contextual chunks from the second brain. This is the second brain right here, and evaluated. This is where the CRAG part comes in. Would evaluate the retrieved chunks, and if it is deemed insufficient or needed additional information, it would go and search for additional tools. And in our case, there are 3 additional tools. The tools are u.com, Google, and News. And the collection of the retrieved chunks plus the possible additional information from the CRAG additional response, all of those get added as contextual chunks to prepare my prompt before I send it to the actual response LLM. So hopefully this is the interesting part, right? So let's take a look, put up all the logos of what are the tech here that we are doing. So the embedding is, it could be any embedding. It just happens to be an easy one. It's the text3 embedding from OpenAI. Everything is stored into a quadrant database. The web crawler is from a spider.cloud. The document processor is Llama Parse. The evaluator is written using the Llama orchestrator. And then the 3 tools are respectively u.com, Google, and Taverly. And then the actual responses of the construction is done using an OpenAI. And the entire reply is done, of course, here on a prototype chainlet. So one other cool tool is let's bring up a PDF file so that we could, or a text file. So so as to try out what the interaction looks like. So if I want to also process a text file, I can go take a prompt there, and let's say in the data set that we have, so I should do a better job trying to find a good piece of text. Hang on. So let's say, let me go to a place that I can find. Oh yeah, there you go. So let me find out something interesting. Let's say, what is so let's say about financial statements. And I want to find out things about financial statement, and the type is a PDF file, so that I can actually demonstrate this. So here we go. What's a financial statement? So usually these are incredibly dry to read. Actually, I want something that has a bit more text. So okay, there we go. So I don't have time to read that. So I would save to a local desktop here. Financial statement, just to demonstrate how this part works. So I would do a load to the desktop. And the financial statement PDF is here. And then I'll ask it to parse. So this is the parsing stage that you saw earlier, where we are chunking up the given text and stuffing it into a quadrant. And you can see the background is processing. When it is done, we all will become amazing financial statement experts. In the meanwhile, while that is processing, let's take a look at what conclusion we have done. So you can see the bottom. Once it finished processing, we'll ask the questions. Oh, it's done actually. Okay, great. So it's done. What are key financial terms in a financial statement? So remember, we are not financial people at all. And now using this second brain, if you could, if you are willing to tolerate the delay, we can be as good as your financial person. So, okay, hang on. What is financial statement? There are several key terms, etc. And presumably this is pulled from the actual document that we have read. It is as good as the document itself. And so, what user benefits are there? Conclusion: finding accurate and up-to-date information quickly saves time and effort, provide you better decision making, ideally, if you understand what it gets back to you, and is potentially a competitive advantage of any professional. Lessons learned. Well, corrective RAG, as fancy as this term means, it does add interesting and sometimes useful information, less than what I expected, maybe because the tools that I selected were not very good. And then the second thing you also notice is Quadrant Cloud, the free version, is not very fast. So next time, we either have to pay more or to select a different tool. So the last lesson learned, this project clearly shows that LLM can be useful with more tweaking to build your second brain. And it's kind of a cool project. And with that, I'd like to say thank you.